In this video, I'll be showing you the solutions to the problems here on this particular worksheet. Starting with problem number 1, f of 4 is what we're trying to find. We see that this graph of f of x goes through the point 4, 2, so that when x is 4, y is 2, so f of 4 is 2. So f of 4 is equal to 2. And a lot of these answers are going to be just estimates because all we have is the graph and it's not clear what the coordinates are of some of the points. Anyway, problem number 1, the answer is 2. Is f of 3 positive or negative? Well, f of 3 is the y coordinate, and when the x coordinate is 3. So the x coordinate is 3. We find the x coordinate of 3. We look down here. Well, any part of the function underneath the x-axis, that's going to be a negative number. So it's negative. I'm just going to circle the word negative. For what numbers x is f of x equal to 0? So f of x is equal to 0 where we have, not y-intercepts, it's x-intercepts. So wherever the x-intercepts are, the y value is 0, y coordinate is 0. So we have x is equal to negative 3. We have, I estimated that other point right there as 3.5. And then we see that we have another x-intercept where f of x equals 0 at 5. Okay. Well, let's do number 4. So number 4, for what numbers x is f of x less than 0? Well, as we can see, clearly the graph is underneath the x-axis in between negative 3 and 3.5. Now, since that's a less than symbol, not including f of x equaling 0, we don't want to include the endpoints, but we want to include all the values of x between negative 3. So on the interval from negative 3 all the way to 3.5. I got to put the less than symbol there. So x has to be greater than negative 3, but also at the same time less than 3.5. Or if we wanted to write that using an interval notation, we would write it as negative 3, 3.5. That's not an ordered pair, that's an interval. So we could write it either way. Number 5, what is the domain of f? Well, if we look at the graph, we can see that I'm assuming that these dots at the end are including the endpoints and there are no open circles along the way. So if I'm assuming that, then I will include negative 5 and all of the real numbers x to 5, greater than negative 5 and including 5 as well. So we could write the domain of f of x as x has to be greater than or equal to negative 5 and at the same time less than or equal to 5. So all the real numbers in between negative 5 and 5, including the endpoints. Or if I wanted to write it using interval notation, I could do that as well. And number 6, if we were to draw so it's asking us for 6a, how often does the line y equals 1 intersect the graph? Well, we just draw a line y equals 1. There's 1 on the y-axis. Y equals 1 would intersect the graph at 1, 2, 3 points. That's it. It's just this kind of a question is just testing your ability to understand the terminology. So just 3 times. Approximate the solutions to f of x equals negative 2. Well, negative 2 is right there. Let's draw a line this time, not just dotted. So negative 2, that's y equals, or f of x equals negative 2. And if I'm looking for solutions to an equation, I'm looking for what variable do I want to find. So the variable I'm looking for is x. And if I'm trying to find the x values that would cause the y values to be negative 2, then I notice that I have an ordered pair right there, 3, negative 2. And then over here, I'm going to estimate the coordinates of that point to be negative 2.3, negative 2. So therefore, the x coordinates that would cause the y coordinates to be negative 2 are both negative 2.3 as well as 3. So therefore, those two values are the solutions to my equation. So we have x is equal to about negative 2.3. and also x is equal to, I think that's 3. And we could write it like this: negative 2.3, all the real numbers in between, not in between, sorry, all the real numbers in this set of braces here. So the set of numbers, negative 2.3 comma 3. Sorry, I didn't say that very well. And what I'm going to do here is I'm going to pause the video, I'll stop this video, and I'll start the new one and identify the local and absolute extrema.